As Surendra said, myself, Venkata Bandi. I did my PhD from Alta University, and I taught in Alta University for 11 years. So the courses actually that I kind of involved are applied mathematics courses. That's how I got introduced to this machine learning fundamentals. Okay, so let's start. So basically the idea of this week's lecture is, what we try is to establish a connection between the AI agent and ML models. You might be, for example, those who are already aware of AI agents or AI, for example, in general. So few years ago, AI means basically uh, LLM models. LLM means like large language models. These large language models are nothing but machine learning models. But those machine learning models are trained on qualitative data. So the qualitative data means basically, it might be it basically a text. They might be trained not lately. I mean, after that, actually, at the beginning, they were trained on qualitative data, that is text. And then actually later they were trained on images. Later they were trained on abstract information too. So in a nutshell, machine learning is very much central to AI and AI agents. So we will see today what the basic concept of machine learning models and how they are related with AI. So that's what we are going to see. So as I said, like AI for AI, machine learning models are like kind of a integral, which basically means actually their machine learning models are brain for this AI or AI agents. So these models enables perception, learning, and decision making. For example, you might be all using smartphones. So when you are using smartphones, when you're trying to uh, type a particular, let's say I'm trying to type a word called like knowledge. So the meaning I start typing K, so it's going to give like some suggestions already. So that's basically nothing but actually, an ML model. It basically perceives and learns and then suggests what would be the word that you might be typing. It might not be 100% accurate all the time, but most of the time it is. The more it gets trained on your data, the better it can perceive, the better it can learn, the better it can give decisions. So what exactly is the benefit of this ML models? Or to that extent, any model. So these models, basically, a model, if you want to define a model, a model could be a replica of a Taj Mahal or a replica of a mobile phone, or like it could be a toy. Toy is also a model, it's an abstraction, right? Basically, whenever we give a cell phone toy, a toy cell phone to a child, he starts to perceive basically by looking at like how we are using our phone, and then he used to emulate that behavior on the toy, which is basically the model. Likewise, these ML models are also, or any model to that extent, they try to mimic the reality. When it comes to large language models, the ML models try to mimic, the natural language. You might be heard of like natural language processing, which is basically a central to large language models. So while making in order to make those models, we need to interact with data. We need to understand actually what type of a data it is. You might be all using OpenAI ChatGPT. So the ChatGPT is being trained on like millions and millions of documents. Those millions of documents, they do have a text, and those texts are written in a particular logic. And then they do have like certain relationships. So these relationships, usually these machine learning models, they usually in the beginning they used to the very purpose of machine learning models in large language in AI is basically prompting the next possible text. But with the evolution of computing power, now we have ML models that provide reasoning. For example, whenever you're trying to, you might be all like familiar, if you have used Google search, for example, few years ago, if you type like if you type like for example, like given over what is an ML model, so it used to kind of direct you to different resources that are available on World Wide Web. But today, if you ask the same question, it's gonna show us, it's gonna direct us to different links. But in the beginning itself, it's gonna show us what it might perceive an ML model is. Basically, it uses this Gemini and then provides the output. So in a way, these ML models, they have to, or agents, AI or agents, whatever, they have to get trained on data, and then these data, uh, and here the purpose of machine learning models is to reduce the error and speed up the process. So if you look at this example, like, if we kind of try to search what is an ML model, maybe let's kind of look at it like just for you to understand, like, what I'm saying. Let's go here. So if I just say like, what is an ML model? So for example, here it's trying to based on like, my search criteria or whatever, it's trying to kind of suggest what would be the next possible word. So what is ML models? So if you say it like, for example, okay, so this isn't finished, but anyway, so it's suggesting actually, what is an ML model? And then later it starts to show us, it's going to direct us to different links. Whereas here, as you can see, these models are so advanced that actually we can also see, for example, Telugu is the language I speak. I hope it works. Okay, so it's not working. So it's not working, but anyway, so they are trying to kind of, so they are trying to show like, they are accumulating the information that is available and try to show us the information before we go to like different links and then study ourselves. So in a way, these models actually what they are trying to do, they are trying to help us, and at the same time, if you want to, for example, if you want to keep on using Gemini, so the Gemini, somebody's like on mute. Hello? Hello, can you hear me? Hello?
Yes, Srikanth, we can hear you.
Yeah. So basically, in a way, actually, whenever we make models, we want to reduce errors, and then we want to speed up the process, right? Like, so that's also a benefit of ML models. So typically, actually, with the increase in computing power, so these ML models can process large volumes of data, and they enable actually this personalization. Okay. So, and in machine learning, actually, also, if you go to some advanced topics, the new machine learning models, they have this continuous learning, and at the same time, they do kind of do this trial and error, because again, any model is not exactly, no model can mimic the real behavior. So it tries as much as it can actually to mimic it. We can see that actually in Instagram. I hope actually most of you are aware of, I mean, okay, all of you are, I think you are all aware of Instagram actually. So whenever we launch an application actually in our mobile phone, an Instagram application, there are so many machine learning models that works in the background to enable us. I mean, that kind of make sure that it's going to show us the content that we watch based on I mean, it's going to suggest us contents that we have based on actually what we have watched yesterday, what we have watched, like for example, few months ago, for example, if it is our birthday, so it's going to kind of rank the, if somebody has wished us, actually, it's going to rank it like upwards. So there are so many things that happens behind. So at least like I just did some simple Google search. So basically, Instagram is owned by Meta, which is basically the parent company of Facebook. They do use up to more than 1,000 machine learning models, and these machine learning models, they do. And then actually here we also need to kind of understand the the sheer volume of data. So at least one report which suggests that you know people produce around 95 million photos and videos are uploaded daily into Instagram, and it does have 400 million users that are active, and with the average interaction time in Instagram is around like 33 minutes, and 100 million people actually they use stories daily. And basically this all this interaction, whatever whenever we swipe, whenever we like, whenever we kind of skip content, so this all this information is being stored, and this information is being, the manual or for example, no data scientist can kind of interpret it, the data, given the sheer volume of it. So which basically, and then as Instagram as a market player, they do want to make profit, right? So they want to kind of promote products and brands. They want to promote products and brands. So in that sense, actually, they also need to understand our interests. To which content actually we liked it. For example, so if I have kind of started liking cooking videos, it's going to show us like cooking videos. Then it might thought like, okay, he might be interested in like you know some utensils or whatever. So it's going to show us like some merchandise information about utensils or like some natural health products or whatever. So they kind of these kind of targeted advertisement or like targeted brand promotion is enabled by machine learning models. And as the time progresses, these hello, hello, Surendra, ఎవరైనా మైక్ మ్యూట్ అయిందా,
Yeah, yeah,
అది
yeah.
అన్మ్యూట్.
You carry on. I'm controlling it. Okay. Yeah.
So as the time progresses, these machine learning models, they are going to become much more efficient with the introduction of AI agents. Right now, these machine learning models are okay, so all of you are aware of this. A lot of things happen behind actually the machine learning models. Now, this is basically a just introduction actually about like the machine learning models. Now, let's go a little bit deep actually into the machine learning models. So, what is a machine learning model? Okay, in simple terms, it's nothing but actually a machine learning model. It learns from the data. What we have to learn from the data? At the end of the day, we want to kind of understand what happened. Why we need to understand what happened? We need to understand what happened to anticipate or to uh, to anticipate or like to kind of predict what might happen in the future. So this is what a machine learning model is in much more simple terms. And how the machine learning model works, at the end of the day, machine learning models, they use existing mathematical models. uh, to understand what happened. And there are like kind of multiple machine learning techniques that you don't need to go, we don't need to go in detail. So the most simplest machine learning model is regression. All of you, I guess, like we are all from India, so we have learned machine learning models when we studied coordinate geometry, regression. So and then actually there is advanced concept called like neural networks and etc. So that we don't see in this course, but regression is something that we are going to practice, and we will demonstrate a case study, and then you guys have to do some small assignment on regression. So you will also build a machine learning model, and then after that, actually, you will kind of integrate that machine learning model into an API that you have developed in your first week. And that API actually we can use it, in the final week actually to, when we start working with the agents. So why we need in machine learning models? As I said, as I said like earlier, so it's basically about like a predictive. It's basically what might happen in the future, and it's basically anticipating what might happen in the future. For example, as I said, when we start typing, so it's going to give us suggestions, right? It basically is kind of thinking, this is what we might want to type. Okay. And what is the importance? Again, as it's basically helps us, it helps machine learning models help in decision making. For example, I work in I will just give a practical example. Right now, I'm working in a public transportation company in Finland. So we do use machine learning models, and our managements want to use AI agents. So as a public transportation company, we have more than 1,500 buses in our, we operate more than 1,500 buses. And the management, they were interested in actually how much fuel is being consumed in a day or in a month, for example. So depending on the managerial level, for example, people like CEO and stuff, they might not be worried about how much fuel is being consumed in a day, but they are very much interested in actually they would like to compare the fuel consumption across months. So and then myself actually I'm working on an AI agent, building of an AI agent actually, which basically try to inform the management actually what would be the energy savings, or energy consumption compared to previous month. How much fuel has been kind of saved, or like did we spend extra, or like and then they want to compare it with like budgeted fuel information. So in a way, these agents have practical relevance. That's why I'm giving this example. So at the end of the day, they help decision making. For our company, they are trying to help in terms of operations. For Instagram or Meta, they are trying to kind of ensure that like the users are actively engaged with their platform, so that actually they could better promote products or brands. So everybody at the end of the day, they try to use machine learning models for decision making. So now let's see a simple example of a salaried salary. So let's make a machine learning model, a small machine learning model that uses a data. For example, here in this column, actually, here we have years of, I think, so this is like a number of rows somehow. And then let me show this in an Excel sheet. Can you all see this? Actually, the Excel cylinder, can you see the Excel?
Yes. Yeah, I can see this picture.
Yeah, so let's see actually, so this is the original data we have. As you can see, we have a column here in B. So here we have years of experience. And then we have another column, a salary actually, okay? So how many data points we have? We have around 30 data points. And in these 30 rows, we have like, for example, if a person is having 3 years experience. So basically the historical data says that they earn 56,643 rupees. Okay, so now let's make a machine learning model based on this. So, the term might be kind of sound too complicated or like too complex or too intelligent or something. But if you start understanding it, they are basically very simple. So let's kind of look at like you might be all knowing. Just a second. Yeah. So let's find first before going there. First, let's understand some basics. Because you might be all coming from different backgrounds. You know, you might have studied coordinate geometry, right? So here I have different points. Here the value is x, and this value is y. So here we have different points. X value is 1, 3, 2, 5, 3, 7, 4, 9, 10, 21. Okay. So if these are the different points, okay, we all of us have kind of used coordinate geometry in school. So I will just try to kind of show little bit small elementary mathematics to demonstrate how we can build a machine learning model with the simple concept. Okay, so if we have like two lines, if we have two points, then if you want to draw a line, for example, let's say if if this is the point, this is 1 3, let's assume this is 2 5. Okay, so if we draw a line connecting these two, and if you want to find an equation of this straight line, okay, then how do we find it? So first we will compute the slope, which is basically m. The slope is y2. Here y2 is 5 minus y1, that is 3 divided by, so x2, that is 2, and x1, that is 1. So what is the slope here? So the slope here is 1. Okay, and then actually if we use like some elementary mathematics, and then when we start writing a line, so I'm not going to waste much of the time here. So I just showed like this m. I mean, I just showed like sorry, I think this line kind of goes from here actually, sorry. Okay, so okay, so basically if we kind of write an equation for this line, so which is basically is y equal to, so here the slope is 2 actually, when you do like some simple maths. So the line becomes y equal to 2x plus 1. So this is the equation of this line. This 2 is slope, and 1 is the y-intercept. So y is basically the distance. This distance is 1. Okay. So this is something this is all you need to know. Okay, to solve your assignment or anything, like at least for this for the next 2 hours or 2.5 hours. Okay, here the 2 is the slope, and 1 is the like intercept. For example, can we check? How do we check actually whether this 4 and 9 will stay there? So let's say if the x value is 4, so what is the value of y? 2 times 4 plus 1, which is basically 9, right? So this is all you need to know. So basically it means the 4 and 9 is also on this line. Okay, so we will use the simple the same concept, and then we will build a ML model, a salary prediction model actually based on this, and then we will deploy a API, and then we will test that API. Okay, so let's kind of look at it. So this is the data. So what we are supposed to do, we use that historical data, and then try to predict, if a new employee is joining, let's assume actually if it is only 30 rows, it's much easier to understand, right? Let's say if your company is having like 3,000 employees, and a person actually a new joinee came, and he has an experience of 5 years. And what would be the salary actually HR needs to kind of decide on? So then they will use the salary prediction models. But again, this is a very simplistic one. But in general, in most of the companies, they do have different metrics, and they in earlier they used to use like Excel. This, I mean, it can be used. We can also do it like with machine learning models. That's a different thing. So for this, we are going to use the simple technique called like linear regression. That linear regression uses just a second. Let me think. So yeah, that linear regressions actually uses this particular equation, which is basically y equal to mx plus c. So this is what it's going to use, which we all have used, during our, in elementary school or high school. So here, what this regression model try to do, regression model try, for example, here, if we know the value of x, we can predict the value of y, right? So here, where the value of x is called independent variable, the value of y is called dependent variable, because we can determine the value of y only when we know x. So this is the principle we are going to use in making a machine learning model. Okay. So for salary prediction, what would be the independent variable? The independent variable is the years of experience. And based on the years of experience, we are going to predict the salary. The salary is a dependent variable. So in simple terms, when we know something, when we know when we know the years of experience, we should be able to predict or like anticipate or like what would be the reasonable salary to give. Okay, that's what we are going to do. And for this, we will use regression model. So, I have explained, right? So this is a line, what I have explained. So you don't need to know like how this model works or whatever. So we do have, don't get, never ever think that actually, machine learning models are complex. As people who want to work in IT, we might not be building a machine learning models. We are the ones who might be using machine learning models. So making machine learning models is complex, but using them is like, you just need to know what would be the command that you need to use that you're going to see in today's session. So now let's kind of go to the Excel and then try to build this machine learning model. Okay. So here we have years of experience. So I will call this, we can predict the salary only based on the experience, right? We can also do it the other way around. We can take salary as an independent variable and predict the years of experience. But that's not something actually organizations do. Maybe if you're an employee, you might be doing that reverse case, but most of the organizations, they do decide the salary levels based on years of experience. That's a very well-known truth. That's why this column is a independent variable. Okay, and then what, like salary. Salary is a dependent variable, which basically it depends on years of experience. So for this in Excel, you all have this Excel access to this Excel in the training, in GitHub. So you can download this particular Excel and then just see the formula. Here also actually I don't need to do anything. I just need to know there is this linear function that exists in Excel that emulates linear regression. It does all calculations for us. Okay, so I entered this particular equation, and then you just press enter. When you press enter, so it's going to fill all these details. Maybe let me show you again. Okay, so now I'm deleting everything data here. Okay, so there is nothing here. Okay, so in this row, I'm just pressing this one. Okay, as you can see, we just need, as I said, you as a people working in IT background, you just need to know the method. Or like most of the people, I mean, not everyone should know, how the method is built or like how to build a method. So that's a job of some, job of others. What we need to know, either we need to know by most of the times, people above will tell us actually what method to use, or by experience actually we know what method to use. You know, after today actually you should be able to know, whenever you want to predict something, you can use linear regression. That's something, if you know that for this class, that's really good. Okay, so now I'm just pressing this linear regression method in the Excel. So as you can see, it just filled all the data. So here again, actually, in the first row, actually it fills this coefficient and then intercept. So as you can see here, the coefficient is nothing but m in our equation, and intercept is nothing but c in our equation. So if I have to write something here, okay, if you build this equation, if I use that linear equation, if I want to predict the salary, so this is the equation I have. If I use linear regression, the salary is equals to the slope, which is 949,9449.96 multiplied by years of experience plus this intercept. Okay, so this is what we got in the Excel. We can also calculate, I will just show you something. Okay, so here, like we calculated the slope for a simple straight line. We can also calculate it. So I'm just calculating it. I will show you. You will get like somewhat similar number. I mean, it won't be as accurate as like that one, but it will be close to that. The coefficient. For example, here I calculated for some other lines, it's 6556. Okay, it kind of varies. So, for example, for this particular number, we got the same number. So it depends basically, like, so the slope will be different, but most of the lines, that means, this model is not that accurate. That's what it means. So here the slope is different for different points, right? So that means this is what it means. So how do we know actually the model is not accurate? The linear regression that we did, that also kind of provides us that information. So this value 0.95, that is the that if the value is 1, then our model is 100% accurate. If the value is like 0.95, our model is 95% of the time accurate. That's what it means. So you don't need to know what other variables are. So this is good enough. Now we have made, now actually what we did, we have this coefficients, right? We have this coefficient, and then we have this intercept. And now how do we predict the salary? So based on this equation, the salary is nothing but 9449.96 times the years of experience. So we just enter that information here, as you can see. So I have hard coded it. So I'm just multiplying it, like, the years of experience with coefficient, and then I'm adding like the intercept. So, and then actually I just filled all the I just kind of calculated it. And then actually here, I just, in this column, I had just have this salary actual. And here, as you can see, there is always this error, as I said, right? So the model is like 95% of the time accurate. So that's why we are having this error. Sometimes actually it is, for example, in few cases, it is really, it's almost near. The error is only 1600 euros. Okay, so when we plot, the red line demonstrates actually the equation. That's why all the points are on the line, whereas actually these points are like the original data. Okay, so this is the simple machine learning model. So here, as you can see, if we have 3 years of experience, how we are going to predict? So we will just simply multiply it with this 94 for 9,449.96, and then we will just add the intercept. This is the salary we get. Okay, so this is what we did in Excel. The same thing can be done with the linear regression models in Python too. So that's what we are going to see. So as I said, again, I'm gonna sum up what I have said about like the salary prediction model. So For example, when we have this historical data with the two columns, one column being the years of experience, and then the other column being the salary. When we have this two columns, and then we have 30 rows of data, and then a company want to use this particular historical data as a reference so that they can hire their future employees when they know whenever they ask for like kind of during salary negotiations. So for that, what we did, we used a linear regression model like this, which is basically y equal to mx plus c. We used that particular regression model, and then we built a machine learning model. We can call it a machine learning model. We can call it also linear regression. For this class, it is a machine learning model. So when we build that machine learning model, this is an equation we got. Salary equal to 9,449.96 times the years of experience plus 24,800. So what we did, we used those values, and based on the machine learning model, we predicted the salary. And whenever we make predictions, right, we always need to tell what would be the score of this particular machine learning model or accuracy of the machine learning model. Okay, so the accuracy is 0.956. Okay, so now we will see basically how we can implement the same with Python. Okay, so that's what we will see. So before going to the Python notebook, I would like to kind of tell you a little more about little more about like machine learning models replaced in practice. So here we just have an equation, we wrote a number and then we predict the salary, right? So in general, actually, when we write like this machine learning models actually with Python, so we use pickle files actually because they are tiny in size and they are faster in response. Okay, that's why we use pickle models there. Okay, and then we also need to understand actually are these machine learning models as simple as the ones that were told? No, because real world problems are like real world data is like much more incomplete. Let's come back to it like later maybe. Yeah. So now I will show you the notebook. Okay. So here you have you can download the data there. So here what I'm doing actually. So here we have. So here with this particular command, actually, I'm loading the salary data. It is basically, as you can see, it's nothing but the same data that what we have. Okay, years of experience and salary. Okay, same data actually. We have 30 rows. Here, don't think like, we have only 29. Usually, whenever in like most of the data, uh, the row number always starts with zero actually. You might see with last class also. So yeah. So this is the raw data that we are having. So here with this command, so here, you all have access to this particular notebook. Okay. So these are like different packages, Python packages that we might be using. So, okay. So first, actually, I'm going to load this package. I mean, basically, I'm going to import actually the packages that we are going to use in this notebook. So it has this sklearn package actually, which is a machine learning model. So let's come back to it a little later. So here, so what we do, here you can see the command. So here we are loading the salary data actually by using, this pandas command read CSV. And then actually here, when we read the salary data, okay, so let's kind of look at like, when we read, have you all know actually, I mean, let's kind of look at this salary data is being loaded into a data frame. I will show you actually how it looks like. Okay, we have loaded the data. So if I print the salary data, so as you can see, actually, I'm just using this Copilot. So it's kind of giving me all the comments. I mean, all the so this is so this is the sample data. As I said, actually, this particular column doesn't have the row numbers, doesn't have any name, but we have like two columns, the years of experience and salary. Okay, so this is the data set. If I want to see the whole data, I can also see it. But anyway, so this is I'm here. I just printed only 5 different rows of the data. So here we are loading this data, and then we are kind of assigning, we are just selecting the salary information and storing it into a data frame called Y. And we are taking years of experience and storing it into a data frame called X. And then here is the beauty of Python. Okay. So I have, for example, here in this package, there is this sklearn package. So from that sklearn package, I am importing linear regression. I'm importing linear regression. So I'm just like calling that particular function here. Salary model equals to linear regression. This is a very simple command. And then next what I'm doing actually, so I'm just like kind of fitting the values of X onto Y. So whatever it has to be done, the Python will take care actually in the background. Okay. So if I run this particular, and then actually what I'm trying to do, I'm trying to print the intercept, the coefficient, and the R square. Basically, the R square value for linear regression, it gives us the confidence. If the R square value is 0, that means our model is really bad. If R square value is 1, then our model is 100% accurate. That's what it means. Okay, so I'm just printing it. You all have access to this notebook. You don't need to. You can go through it. So when I kind of run this, so the same thing happened. As you can see here, what is the coefficient that we got? 9,409 449.96. What we got in Excel? See, it's the same thing. So here the intercept is 24,848. So the intercept is same. So even the R score is same. So with Python, whatever we can do, whatever we did it with Excel, we can do the same with Python. Okay. So, and this is the score. And what we do with this machine learning model, so what we can do, we can first, as I said, actually, we can, if you want to use that model, we can use pickle files. So there is a package called like, pickle that we are imported already. So we use that pickle package to write that model, the salary model, into a pickle file. So we have named the pickle file as salary model.pkl. So as you can see, maybe I'll just delete it. I'm gonna delete this one. Okay, so we already created the model actually. Now we are gonna write that model into a pickle file. See, so it has created the pickle file. And now after we create the pickle file, actually, then actually this pickle file is built. Yeah, sorry. After this pickle file is built, we can use that pickle file number of times. Like for example, okay. So here we are using this pickle file locally. Okay. So if I'm just opening the pickle file, and what this pickle file does, it's going to ask us for an input. It will ask us actually what, the number of years, and then it will print what would be the value of, what would be the expected salary. So I'm going to run this cell block here. See here, it's asking actually what would the enter the number of years of experience. So let's say actually, let's enter 5. So what is the predicted salary? 72,998. Let's see in our lecture slides. What would be the salary for 5 years? See, it's the same thing. So whatever we do, as we have used linear regression, all the values are going to stay the same. Okay. So And then after that, actually, we have built this model.api. I think last week Surendra has explained how to convert a Python program into a function. So here you can also see we have created an API with the fast API, and then we have created a we have created a actually to we have created a function to get the salary actually based on the experience. And now I'm going to run this API and we'll just show you. So this is an API. So this particular API is hosted in this particular address. So 127, this particular address. Let's go to that. Okay. So, and then as you can see, this is how you can use it. So, basically this is an extension of, so this is an extension of the API. Okay. So here we can give the input. So this is the address of API. So I'm just like kind of posting it. So I just posted like 5 here. See, we got the same salary, 72,098.115. So this is the same value that we got here. So here the biggest problem is actually when we are running it in the cell code, we can run it only once. Whereas here we just need to kind of send the request multiple times. We could send like 7, it gives us 7. Okay. Let's say like if you give it like kind of 10, it gives if it is 1. So basically the use of Surendra might have already explained why we need APIs. API makes jobs much easier, and we can use the programs on call. That's the biggest advantage of APIs. Okay, so this is what we did. So don't ever think that actually machine learning models are complicated. Yes, machine learning modeling is complicated, but not everybody. I mean, I think very few they work on building the models. Most of us they work on using those models that somebody built. For example, here somebody built a linear this scikit-learn package. The scikit-learn package is like a very powerful. It has like a lot of algorithms. It has neural networks. Again, in neural networks, they do have different techniques. Random forest is like the one of ones. Some people use nuclear fission as nuclear fission for as a machine learning algorithm. So I'm just like explaining. You don't need to think too much about it, but it's very simple. Okay, so this is what is this. In very simple terms, this is how we can make a salary prediction model. So yes, Bennett.
How is that the score is predicted? Like the prediction score, how is it calculated? Because like now we have given some kind of data set, and of course it calculates the coefficient and intercept, and fine, that is fine. But I don't understand how the prediction score is calculated. Like say how it is like 95% accurate and so on. What is the basis for that?
So the prediction score is calculated by something called like root mean square error. So it's calculated with this root mean square error. So as we can see from here, so when we predict those values, for example, even for these values, our prediction is going to be here. Not here, not the yellow dot. So it basically, as the errors will be either on the positive side or on the negative side. So we are gonna make the square of the error, and then we divide it with the original value. So that's how, and then we make a square root of it. So it's nothing but a root RMS value, root square error. That's what it's called. So, if we just add them together, if we just add the errors together, it's going to be 0, right? So in order to avoid it, actually they square the error and then they sum the error and then they divide it with the number of points. I think
Okay.
that's so.
So it's more like a distance from that line. So how far that particular point is from that line, like
Okay.
So it basically tells actually 95% accurate means, okay, mathematically speaking, 5% of the time the points will be either side of the line, not on the line. That's what it means.
Mm.
Yeah.
But if that is the thing, given this data points that we have right here, most of them are anyways not on the line, right? So that
But
that doesn't.
so here it's again it's little mathematical. Like so, for example, here it's not the case because actually here we have these variables are discrete. They are not
Mm.
continuous. If we
Okay.
are going to have the
And
values
so
like 1,
yeah. So
1.1,
and
1.2, 1.3,
mm, okay.
yeah,
And
if we have like kind of continuous, yes.
yeah, and so the thing, for example, the formula that you stated, like squaring of this deviations and so on, is that applicable for any kind of model? I think that should be the case for any model, like say linear or
Uh,
whatever, or the prediction score. The calculation of the prediction score basis is like pretty much the same, or it will be different for each models.
So that okay. So basically, the more advanced the models are. So
Mm,
when it comes to linear regression, so this is what actually they expect, they
okay.
do. But actually, when it comes to like kind of when it comes to other mathematical methods, so
Mm,
you will have this probabilistic modeling actually, but the concept
mm,
is similar.
okay.
Okay, the concept is similar.
Mm,
It's basically then we might be using like some probabilistic methods.
okay.
Yeah,
Okay. Yeah.
we will be
Okay.
using.
So it could be different. Yeah. Yeah. I understand. Okay.
Yes, yes,
How
it
it's
is
calculated.
different.
Okay.
Yes, yes.
Thank you,
Any other
Shubham.
question? Yes, yeah, thanks. Any other question? So we could go on then actually. So before going actually to the today's your assignment and this is a very simplistic case. Now let's look at like one real-time case. I mean, not real-time case, a case that might be relevant to you, all of you actually. Most of you are like students. So we took a data sample. So we took a data sample and how we are going to use the data sample to make a machine learning model. Okay, so that's what we're going to do. So before going to that, so I just want to you kind of give you a little bit brief on how does a machine learning workflow looks like. Okay, this is just a brief. So for any machine learning model, even actually with an for an AI agent, for AI agent, so it's basically more about actually we define the goal. After we define the goal, we do this data explore and data prepare, data exploration, data preparation. So this is the second step. And after we do this data explore and preparation, then we train and validate the model. So earlier, right, what we do, what we did, we have used all the data to make a linear model, regression model. Whereas actually in this train and validate, we are gonna take only 70% of the data or 80% of the data, depending on actually the data quality. So we are gonna take it and then we are gonna train the model on the training data, and then we are gonna test the developed model on the test data. That's what we are gonna do. And if we are satisfied with this, and then we are going to do like multiple iterations and until we get satisfied with the validity of model. So once we are satisfied with the validity, then we are going to deploy the model. And then actually after deploying the model, we have to this monitor the model. We might be getting like new set of data, or like the users might tell us that your model actually is not working according to our expectations. Then actually we again actually monitor the model, and then it goes through this life cycle actually. Okay, so why we need this machine learning workflow? We need this machine learning workflow to address data-related challenges. Okay, so this is workflow we follow. So
Shrikant, one question.
yes.
Yeah, quick question. So sorry, dumb question maybe.
Sure.
So yeah, in this one, like say the training and validation, right? So of course we are training the data, and then you said that of course if we are not satisfied with the model itself, then we iterate. Like say, of course, what does iteration here mean? Does it mean that we are changing the model, like say totally, like say from regression to some random forest or whatever? That is that. Does it mean that?
Yeah, so basically that's what we are gonna talk about it next.
Okay. Okay.
Okay, so basically, so that's what we are gonna talk next actually. So here, what we need to know, so this is the, for example, like the workflow as I have explained, okay? And then let's kind of go little bit, little deep. So little bit first, let's kind of go through like different packages that are available actually in Python for machine learning. We have PyTorch, we have TensorFlow. I think TensorFlow is developed by, if I remember right, TensorFlow is developed by Google or something. I forgot anyway. Yeah. So basically, I think Meta, Facebook, I guess. I don't. I think they use like some of them, and then there is this XGBoost. There is this Lite GBM. So all these different packages, actually, this Python frameworks, they do have different purposes actually. So these are like traditional models. So if you want, you can explore actually these frameworks and what they're being used for, and what kind of a models actually they accommodate. You can always see it. Okay. And then actually, so in this class, actually, we are going to use the scikit-learn. Now, the scikit-learn actually is very much, it's very powerful, and it's very much useful when you're a beginner, and to do most of the traditional ML tasks. Okay, in this class, we are talking about linear regression. So for understanding linear regression, now Bennett has asked the question, right? How we are going to validate and train the model. So for that, we need to know two concepts for it. One is correlation, the other is causation. So you always need to know the distinction between the two. What is correlation and what is causation? Okay. So the correlation is basically a relationship between two variables. For example, if a what would be the good example? The speeding, drunk. What would be a good example of correlation? I mean, it could be as simple as actually, yeah, it could be as simple as actually, the food intake. The food intake is correlated with the age. That could be a simple example. Or the student marks are correlated with the number of hours they study for the exam. Or the salary is correlated with the years of experience. So that is correlation. And causation. Causation is like more of a, uh, you know, is causation is more like for example, one good example. Okay, okay, a student actually, for example, a student going to a good college, in the beginning has to be, does it need to get like either good marks or like good rank actually to get into a good reputed college. But it doesn't mean actually, it doesn't mean that they are going to score high in the exam. So for scoring high in the exam has is not correlated with like it doesn't. Okay, maybe let me explain this again. Correlation causation is a very challenging topic. Let me explain in a much more simple terms. If a person gets a good rank and then he goes to a good college, it doesn't mean actually he's going to score high in the exams. For scoring high in the exams, he has to study, he has to put efforts into preparing for that exam. So preparing for the exam causes him to get good points. That is that is like causation. Okay, and getting into a good college has a correlation with good rank. Okay, maybe so. This is a very complicated. Once basically what they tell is in modeling, once you understand the distinction between causation and correlation, so your job is almost 80% done. So that is the most difficult concept. So Bennett, actually we use these principles actually to really validate any model, whether something is correlating it or like causing it. And for that, as these concepts are like kind of a little bit complicated, we do have like different metrics like R square, this root mean square, the root mean square error actually it kind of tells us, how much the data is correlated. For example, we can see in Excel, I will just show it. So for example, we can also we have a function called like correlate. It kind of tells us actually the array. It can it tells us. So here the correlation, as you can see, it's like kind of 0.97. That means, they are kind of linearly correlated actually, as the value of X increases, the value of Y also increases. That's what it means. Yes, Manisha, you have. So that's what correlation and causation means. So now, as I have explained, like, linear regression, let's look at a simple example that we are using in uh, in this lecture this week, and the assignment we are going to look at, and you all have access to this information. This is student performance information, okay, in the format of CSV file. Okay, so here we have different information. We have hours, we have hours studied, we have previous course, and then we have extracurricular activities which are being kind of set like in the form of yes or no, and then how many hours a student is being slept, and how many sample question papers he has answered, practiced, and what is his performance. So we have 5 different columns here. Okay, we have 5 different columns here. For example, this particular student has studied for 7 hours for the exam. His previous score is 99, and he has extra cultural activities, and he slept 9 hours a day, and then actually he has practiced one test paper, and then his score is 91 in that exam. So likewise, we have different students actually here. Altogether, actually, we have more than I think we have the information of we have around like 10,000, 10,001 students actually. This is the information we have. So given these variables, can we make a machine learning model that would give us some insights into what would be the if we give an input on our studied previous course, extracurricular activities, sleep hours, and and how many sample papers they have practiced for the exam. So if we have this information, can we tell what would be the predictive score? That's the objective that we have for today. For an assignment. Okay. So let me kind of just give me a second actually. So I have information we have. Now let's use the same method and then try to build actually a machine learning model for it. Okay. So this is the student performance case study. So we have the student performance case study. So here the data set actually, you can, this is a open data set that is available in Kaggle. So, there are like kind of, many people have worked on the same data set, and then they have built ML models, and all of them have like their own different scores. Actually, I mean, basically the score of them, I mean, how accurate are like, what would be the confidence? I think maybe the better way of saying it is actually mathematically the confidence factor. So what would be the confidence factor of this machine learning models? Actually, more, you can see it by going to that Kaggle database. So here I have given a link. We have given a link to it. So you will all get it. So and then actually, as I said, this data set has like 6 different variables, and herein, as we want to predict the student performance based on other parameters, the student performance becomes the independent variable. Okay, this might be, and then we have 5 other variables. These 5 variables might not necessarily be related to the performance index, or they might be related, or they might be strongly related, or like or they might not have significant effect. Okay, so this is something we need to understand. For example, student attending extracurricular activities might be also doing good in studies, right? So the student who might be studying more hours might not be scoring high in the exam. So, so there are like kind of these distinctions actually, because, the data, when it comes to like data, it's very difficult to make meaning out of it just by looking at like those variables. Okay, now we are going to follow we are going to use the ML workflow that was shown earlier. So we have this, what's our goal? We want to predict the student performance index given the set of variables. And then what is the second step? We have to explore and prepare the data to ensure that actually the data is of high quality and integrity. And after preparing and exploring the data, we have to train and validate the data. After training and validating the data, we have to deploy it. And then actually after deploying, we need to monitor and manage it. Okay. So this is what we need to do. First aspect is very much clear, right? We have our goal. So the goal is basically, this is the student performance index study. So we have a data set with multiple study and lifestyle related variables. So herein, what would be the lifestyle variables here? The lifestyle variables are extracurricular activities and sleep hours. And what would be the study related variables? So hours studied, previous course, and sample questions practice. So these are study related variables. Okay, now I have to tell you one thing that you all should remember. Whenever somebody tells you, it is a model. Okay, a model is nothing but an abstraction of reality. And there is a saying actually in mathematics, a model is as good as its assumptions. A model is as good as its assumptions. Now, let's say we want to build a student performance index. Different people make different assumptions. For example, a person might have a opinion that extracurricular activities or sleep hours doesn't have any effect on student performance. He might exclude them completely, despite the data set is having those two variables, that person might be ignoring those two variables. If he has the opinion that actually only our studied previous course and sample question papers are the metric. And then actually there might be someone actually who might have the opinion that only previous course are the good indicator. So he might take that only one variable. Basically, whenever that means he is making an assumption that for predicting the performance, that variable is good enough. So as I said, the basic fact that you all need to know is a model is as good as its assumptions. The assumptions usually come from humans, right? So there is always this subjectiveness to it. That's why we have to validate the models. If somebody has to use it, If somebody has to use the model, we have to validate that model. For validating, we do have like different methods actually. Okay, like a root mean square error in this case. Now, let's kind of go through the next step. And then the goal seeking is very much clear for us. It is about making a machine learning model that predicts the student anticipated score if we give some input, whether it could be previous score, sleep hours, or whatever. So, okay, then it should be able to predict actually what would be the score. So the next step is data exploration and preparation. So, whenever this is the most, I myself is working on like building an agent model, right? Most of the time, uh, I have built a machine learning model for my work, and I have spent about more than 2 months in data exploration and preparation. The machine learning part was done almost, in 3 to 4 hours once I clean the data. Okay, after that, actually, the training, after that, the validation of the model actually took time. So actually, the application of machine learning model is the most easiest. The most complex parts are like data exploration and preparation and model validation. These are the difficult parts. So in data exploration and preparation, most popular things that what we need to look at is these 5 characteristics. So we might have this data type inconsistencies, and we might have duplicates, we might have null values. We might need to, when exploring the data, actually we need to find the variables that are correlating it, the variables that are causing it. Okay. So this is something we need to think about. Now, I just have a question for you. In this particular data set, what do you think is the variable that has highest correlation? What do you think is the variable that has causation? Anyone?
Mm, yeah.
Just guess.
Yes, just a guess from my side. So for highest correlation, causation, I would say the sample question papers practice, in my opinion. And for correlation, I would say the hours studied would be the highest.
Yeah, I mean, the causation part, you're absolutely right.
Mm.
Causation part, you're absolutely right. I think our studied actually in this particular data set is not highly correlated actually. Let me see it. I don't
Okay.
remember.
Is it previous course then?
Yes. Yeah, yeah. So
Okay,
basically,
okay.
the previous course has like a highest correlation in this data set. It might
Mm,
be that actually it might have, but causation actually you are correct.
mm.
Okay, you're
Yep.
100% correct on it. But again, when we look at this map, we're going to see it like later.
Mm,
So the causation actually is not explained here. It's only zero. The correlation is 0.02, but the causation is very high there. So
mm,
this is a very correlation causation is something that is difficult to understand. But yeah,
mm. Yeah.
your guess
And
is
also
correct.
it depends like how do we like it also depends on the person who is like working with the data, how we interprets, right? So that will also be a factor. And that is why then you have this multiple iterations and so on.
Yes, exactly. So basically,
Mm,
so usually people who make the models, actually, if they are not domain experts, they
mm,
do have to toggle with different interpretations and then show
mm.
it to like kind of subject matters experts or whatever.
Yeah.
And they have to take inputs of subject matter experts.
Experts.
Otherwise,
Okay.
actually,
Mm.
uh, people tend to miss the effect of correlation and causation.
Oh, yeah.
So
Mm,
it's much easier to identify correlation, but
mm.
causation is something it's very difficult to
Mm.
identify. Yes.
Okay. Yeah.
So now,
Thanks.
so we are gonna make this ML model now. Okay. So I'm gonna just build. Here it's nothing but here I'm just building like taking out this particular data. Okay. So here is the student data. So here also we can see it like, if you are all, I think course has this prerequisite that, you all need to use like some sort of a ID tool for visual code kind of stuff. So you can also see the data from here actually. So here, this is the student data. So this is the data frame. So this is how it looks like. Okay. So here also it gives you some information. Whenever you're using it, right? Like try to just open it and then explore the data yourself. It also kind of gives you some information here. As you can see, how many missing values are there, how many distinct values are there. So how many distinct values are, for example, here, as you can see, if the data is too, here we have text, right? Here it says that it has only two distinct variables. That means this value can take either yes or no values. For example, here the sleep hours are 6, and the distinct values for maximum is like 10, 9, and this is how the distribution of those values are. Okay, so here also it gives us like the sleep hours minimum is like 4. It has this counts and stuff. So usually this data wrangler is like much more useful if you are working with the data in Visual Code. So and then then actually here I just printed it. Okay, so now we have to do data exploration. Either we could do it in this with this view data, and we can do some data exploration, and either we can just print it like this head command. Actually what it does, it prints the first 5 statements actually. Okay, there is also, if you want like kind of last 5, then we just print like kind of tail. Okay, so it just gives us like last 5. Okay, so we can also say like last 10. So it just gives. Python is much more how to put it, user friendly in that sense. So this is the data. So if you are from IT back, I mean, basically, I'm just like interested actually. Do you see any problems with this data at this current point? Whatever we have explained with like linear regression, do any of you see any challenges with this?
Yeah. So for the linear regression, so it's like X and Y, two factors are there, but here there is more factors involved. So
Yes.
that could be one. Yeah.
Yeah.
Yeah. So how do we fit that into a linear regression? Because if we had just like say two or something, then we can train it and then of course use the linear regression. But when we have more, then how do we do that?
We
Like
still
say
we
more
still
factors.
we still use linear regression here, but it
Mm,
becomes there actually it's a single variable linear regression problem.
mm.
So in this case, this is a multiple
Okay.
variable linear regression problem.
Okay. So it's possible to do that. Okay. Yeah.
Yeah, it's possible to do it.
Okay.
Is there any other thing actually? For example, whenever we are used to like why we are using underscore here. It's much easier to complete, right? Usually whenever we have spaces and stuff, that's like not good actually in terms of programming. As you can see, this data is kind of modeled as like without spaces. you know when we are saying like data exploration preparation, there could be simple things like this, hours studied, it's with spaces. So which is basically not good. Whenever it's not good to have spaces actually in name fields. So that's something actually is something we could really see directly. And the other problem is actually when we talked about like regression, right? So we are talking about numbers, but herein actually what we have characters. So which is also, the characters is also not good. So we can convert them to quantitative information. Okay. So for example here, as I said, sorry. Hello. Yeah, sure. So basically, here we have spaces. So the spaces is not good. So basically we just use some command and then actually we remove the spaces. And as I said, the linear regression models actually they work with only numbers. These are not language models. So these are like kind of numerical models. So basically we need to convert those yes and no information into numericals. So here we just model them into numbers. Okay. And then actually then we can just change the data set and then we can just run in the commands. Now you see it's much easier. So I will show you basically the use of like kind of removing spaces. So if I am just like space, so basically this sleep hours is like kind of it's always good to have like that type of without spaces. This is able to predict like much better without that also. So there are like kind of uses for it. And then the other problem is actually, duplicates. Whenever you have data, you always need to check for duplicates in the data. Again, Python is so good. So we don't need, with single line, actually, it will just kind of get duplicates. And then, we can just remove the duplicates with this command, drop duplicates. Okay. So we can check how many duplicates are there in the data. These are the basic steps that you need to do actually whenever you have a data set. These are the first and foremost, check for naming conventions, check for what kind of a model you want to employ. Does it have any, does the model can take quantitative information or a qualitative information? Okay, does it have any duplicates? And here, as you can see, these they have 127 duplicates. Okay, if we are training our data with okay, this is like not much given like 10,000 variables. For example, if we have like kind of, let's say 5,000 if you have like kind of 6,000 duplicates or something, 7,000 duplicates in the data, then it's not good, right, for making our model. Okay, so we have to remove that duplicates. And then actually we also have to check for null values. Are there any null values? So for example, in this data set, there are no null values. So then we are good. Okay. So if you are having null values, for example, let's say actually we have a okay. Let's say actually in this data set. Okay. Let's say we don't have the value here. We don't have the value here. Okay. Then actually either we could do what we could do actually, either we could simply remove actually those two columns, sorry, those two rows, or we could put some value there in those two rows. So if we remove the two values, that's also fine. If our data set is like quite big, but if your data set is small, then removing the columns is not good. Then what they do is they are going to fill that information with either using like a mean value or a standard deviation value. Okay, that's how actually they are going to fill it. So basically, there are like different techniques actually to handle null values. If you are interested, actually do check them. Actually, what would be the techniques that are being used actually to check for null values? Okay, do check them in your after the class. So after that, the Python also has a very good tool called like describe. It basically gives us some information on like on the data set. Basically, it gives us like kind of 20 percentile, 50 percentile, 75 percentile, and then it also gives us like how many rows of data it has. So it gives this information. So with this describe also, you can kind of if you are building an ML model, so you can go through it. So this is like a little bit out of scope for this lecture, so that's why I'm not going within that lecture. So here, what else? So after that, so we have talked about correlation, right? So now Python also has this function called like correlation. So I'm just kind of plotting that correlation actually. So here, so these are the commands actually to plot the relation. So you don't need to worry about the code. You can all access it within the GitHub. Okay, so this is the code. So when we run the code, so this is the map that we get, correlation matrix. So this is what this map helps us in making the regression model. Okay, so in making the regression model, so it's always good to take variables that are with high correlation. Okay, So the variable with high correlation is the previous score, and followed by hours studied. So these are the two variables that has high correlation. For example, here, as you can see, maybe I could show in the lecture slides itself. Maybe it's much better. So these are the correlation matrix. So one means they are highly correlated. Okay, so this is a matrix. Don't think, here it is one, because so here hours studied, here hours studied. They are 100% correlated. That's why actually it is one. Whereas for others, actually they do change. Okay, so the correlation is like 0.92, and for the performance index, the correlation is 0.04 for sample question papers practiced, and sleep hours is 0.5, extracurricular activities 0.3, 0.92, 0.38. So here I would like to tell you a little bit on what would be the difference between linear regression and multivariable regression. Okay, nothing much. It's basically the same. You might be have seen, like those who have studied, like in our intermediate, might have seen some equations. So f of x, maybe let me type, actually it's much better. So we might have seen some equations like f of x, which is basically equals to m1 x1 plus m2 x2 plus m3 x3 plus c. You might have seen like this kind of equations. So this is nothing but actually a multi a it's also a linear regression, but it's just that it's a multivariable regression actually. So y, that is f of x, is m1 x1 plus m2 x2 plus m3 x3 plus so on and so forth. Okay, so the same thing actually, that's the equation that we are trying to build, but rather than building it with Excel or with our hands, we are using Python and machine learning package called like scikit-learn. So that does the job for us. Okay, so this is the graph. So after looking at it, so the good correlation is with previous course. So that's the highest correlation. The other variable is with hours studied. Now, like then actually let's also look at like then we have to kind of identify the causation also a little bit. That we don't need to look at it. This is beyond the scope of this lecture, but I will just give you a little brief how to do data explore. Okay. So for example, we can also look at like kind of previous hours, how many previous hours they have studied. Okay. Then we could kind of little bit check actually like kind of, how many data points are there for each. Okay. For sleep hours, how many data points are there. And we can see the same with, we can see the same with, uh, we can the same with previous paper I explored, so like that we can do. Okay, so which is basically it gives you a little bit idea of like you have to go a little bit deep into the data and understand actually what kind of influence that we might be having. We can't simply, in practice, we can't simply ignore these three different columns as they have low correlation. We can't simply ignore it. We still have to account for it. They might be having some effect. How they have effect, you actually will see it actually in your assignment. Okay, how much effect they have. And then after that, so what we do now, let's come to our machine learning part. How we are going to do the modeling. So basically here we, for example, what are our variables? So our variables are not all the variable, our dependent variables are all, but not this performance index. And our dependent variable is the performance index. So with this data frame, with this simple command, we are going to split the data into two different data frames, X and Y, X being the dependent, independent variable, Y being the dependent variable. Okay. Now, based on this correlation matrix, what we will do is we take we've only take the value of previous scores. And then actually, no, the dependent variable will still stay the same. Okay. And then actually here, this is the most important aspect here. So what we are doing is here we are defining the test size. This is basically just a command actually. If you can read it. So we are creating 4 different data frames called x1 train, x1 test, y1 train, y1 test. And then actually we are using this package. We are using this function called train test split. And here we are giving the input data frames. And then actually we are telling it, okay, just give us the test size of 0.2, which means that actually it's going to define it's gonna take 80 it's gonna split the data into 80% and 20%, and 80% of the data we are going to use it as train data, 20% of the data we are going to use it as test data. And then we have this random state actually. So the random state, what it does, it's also an important aspect to consider. What the random state does is it's going to ensure the uh, reliability of the model. If you don't give this random state, then every time when the split happens, the split happens randomly. That means the data get distributed. Whereas with this particular random state equal to 50, what it does is, so it's going to always divide, when we are testing the model, right? Like when we are testing the model after building it, it's going to divide the data set into the same, we are going to always we are going to have the values in x1 train same, so that we can score the model in terms of accuracy. Okay. And after that, so we can just maybe so let's kind of first let's run only on. So basically, so after running this, as you can see, so basically the 80% we have around like 9,000 points, and then actually the 80% of the data it went to train set, and 20% of the data went into test set. For example, with the simple commands, here we are calling the linear regression model. And after calling the linear regression model from scikit-learn, we are just fitting the data. And then actually after that, we are just printing the data. So here we got this intercepts and coefficients. So here, how do we predict the scores from here? So the predict the scores based on previous scores. So as you can see, the coefficient is like 1 and the intercept is minus 15. Let's say if the previous score is 100, if the previous score is 100, then what would be the anticipated score? 90 times 1. So here what you can see, with this equation, what we can write. So basically, so the equation will be something like this. Let's say coefficient equals to 1 and intercept equals to minus 15. Okay. So if the score is, let's say the previous score is, if the previous score is like 10, sorry, no, previous score is 100. So the new score will become, predicted score is, but see here also, okay, it's saying it's giving us already. So this is the use of AI. So it's kind of just telling us like, just kind of, see how easy it is. Okay, why it's like, this is what we got, right? So this is the predicted score, 86 point something. So even with our prediction, actually, we get something similar. I have a little bit, so here also, we got something similar. Anyway, if I kind of put all these variables, it will be a little bit different. But yeah, so basically the equation is something similar. It's again, y equal to mx plus c form only. That's why I'm just trying to show you this one. Okay, so this is the score. And then actually here, the other important aspect to consider is the model R square score. So the R square here is what? It's only 0.83. That means our model is not that great in terms of confidence factor. Okay, so do we have other set of variables, right? Now we have to test it, like, so this is not good for us. So the model actually cannot be validated actually if it is the R square is like 0.83. So now let's consider these two scores. So these two variables based on this correlation coefficient, okay? Based on the correlation coefficient, actually, let's consider our studied and previous scores. If we use our studied and previous scores, and now again the comment, you have access to this. Now I am just running it. Now, as you can see, if we are using both variables, the score is what? 0.985. That means, let's say, it again depends on actually the people who are modeling it and the people who are decision makers. The people actually who make this model, they will go and tell like, okay, we got this confidence factor of like 0.985. Are you okay with it? If they say they're okay with it, they no longer are going to do any iterations, and they will stop iterations, and then they will deploy the model. If they are not satisfied themselves, or like if the decision makers are not satisfied with the or like the subject matter experts, if they are not satisfied, then they are going to do second iteration. For example, like here, what we did in much more simple words. So first, we made the linear regression model with only one variable, okay? And then this particular iteration gave us the confidence factor, I mean the R square value of 0.83, which basically we are not satisfied. That's why we have kind of consider the second variable, I mean the second other variable also, and then we have made it a model. Okay, let's see actually, let's use some other parameter. Let's say sleep hours. So if I use sleep hours, what would be the confidence score? Can you see? So if you see if we just use like the confidence score, it really went down. If I combine the two, if I use sleep hours again, the confidence factor is still like same 0.983, like in the earlier case 0.83. So, whenever you're validating it, actually, you always need to make sure that, you know what you're doing. But anyway, I mean, so this is something actually you need to kind of little bit know. So now I'm very much satisfied. Like at least like, when we are kind of doing this. So here there are some other factors actually you can use, but here we are just using it. So the R square value for case one, which is basically whenever we consider only one model, it's only it's 0.84, and then whereas in the other case actually it is 0.98. Okay, so this is something actually you need to take a decision on. After doing it, then you need to use same technique. Okay, so you need to use like the pickle file you need to create. Okay, why again? One reason actually I kind of forgot to tell. So why we have to split the data? So sometimes what happens is actually some mathematical methods they do overfitting. So when they do overfitting, they might not be good. So just need to know like in ML models overfitting is not good. Okay, so that's why actually we split the data into training set and testing set. Okay, and what we did, initially we considered only previous course, and after that actually we have considered previous course in addition to study hours. So that's basically called like kind of either validation or retraining or fine tuning. Basically you whenever you're building machine learning models, you need to kind of uh, fine tune the models actually until your validation score is satisfied. And after developing those machine learning models, what you do, you kind of create a pickle file like I showed in the example, and then and then after that actually you create that pickle file and then deploy it in a API so that actually it can be used anywhere. For example, in our course, we are deploying that API in a local machine as in a local host, and you can use that API. So these pickle files are small, and they do include they serialize this data and then data model. The pickle file makes it easier to retrain. Again, that is like beyond the scope of this code, so I'm not explaining it. And the pickle files are simple, they are efficient. As I said, they do support this incremental training. So for you actually the assignment is, so now we did the model actually with only two variables, right? So we still have like other three variables. You can train the data on the for other variables as an assignment, and then you can build a pickle file. You do have an example actually how to build a pickle file here, and then you have an example of how to use it in the API. So we will provide you instructions actually, you know how to do it. Yeah. So that's and after deploying it, right? So these machine learning models, these APIs can be used in as a AI agents. For example, as I explained in our company, so the management would like to know what would be the fuel consumption of last month or last year. You know, basically we are building APIs actually like kind of on our database, so that like whenever they ask for like just as we do have our own uh, we do have our own agents actually deployed within our organization. When they just ask actually what would be the fuel consumption, it just gives the input. I mean, they don't need to kind of go to the database, or like they don't need to open a Power BI and look. So the data will be always available. The AI agents actually, they do all the hard job and then just make the data available for management for decision making. And just as a final, actually, the same model actually, I didn't use it in this thing, but I just want to show you actually a little bit what I did. The same linear regression model can be built with neural networks also, but it just that the code will be little bit, it's more long, little more command lines. But then actually, when we are building actually the model with the linear neural networks, so the R score we're gonna get is like around 0.98. So and then it took about for building with the neural networks, it took about 7 or 8 minutes. So again, as a people actually making it, you need to know uh, you need to know basically what model you need to use. Okay, I'm gonna sum up. So this might, I hope you understood something, but I will tell you 5 simple points to remember after this lecture. Okay, 5 simple points to remember. The first points, machine learning models are integral for AI agents, for AI. Okay. Second, machine learning models, they follow a workflow. The workflow involves goal, data preparation, and data exploration, train and validate data, deploy the model, monitor and retrain. Okay, so this is the second point. And third point is linear regression is a machine learning method, and which is based on like coordinate geometry, that we learned in school. And it can be and Python has a framework called scikit-learn, and with that scikit-learn we can do regressions. And third point, prediction. For simple predictions, actually, we could use linear regression. And the last point, actually, pickle files are the, when we want to deploy machine learning models, we can use pickle files. So these are the 5 points that you need to remember. I mean, if you want, you can explore on the concepts that I have told, what is correlation and what is causation and other things. But if you can remember these 5 points, and then if you can use the existing code that we gave you in the example section, And if you can just go through the data, and then if you can kind of run the code, that's good enough. Do tell us actually what would be the, if you want, we given you the link to this Kaggle data, Kaggle. There you will find a lot of code that people have written. You can also explore if you want to understand ML models in detail and the linear regression in detail. Yeah. Any questions?
One question. So, of course, you were showing about all these correlations and how we are using that data for training. But then, like causation, we didn't, touch upon, right? So
Yeah.
why? Yeah, because like, of course, we can use like that particular column, like the causal column, as part of those training data. But then, is there any di difference how we use the correlations and causations?
So in this model, actually, in this model, actually, the if we use correlation and causation, right?
Mm,
So, for example, okay, how to put it? So if you use like, when you do the assignment, actually, you will see how much causation actually the other three parameters will have in in determining the student performance index. So the R square score is gonna improve a little bit, but not
mm,
much.
mm,
So it's always about actually, uh, okay, what would be a simple example actually to explain it? Yeah, you might need to, okay, I don't know how to, okay, for example, if the causation,
mm,
let's say a very simple example of like drunken drive.
mm,
Okay, so drunken drive is kills is a cause. People. It's a very difficult concept actually, causation. But okay, what would I'm just thinking. That's a very good question. Actually, I'm not able to articulate. But let me just give me a
mm.
second. Actually,
Yeah, sure.
people who are drunk and who drive the car. Okay, most of them
Mm,
they reach home,
mm,
right? Very few of them, whenever there is an accident,
mm.
because their cognitive abilities are kind of a little bit and not in a good stage or whatever.
Yep.
So they do end up in like kind of in a worst scenarios. Drunk and drive causes accidents. That's the
Mm,
causation.
yep.
But if you see the number of people uh, that die when they're drunk and drive is less.
Mm. Yeah. Okay.
Okay,
Mm,
so that's a kind of a less percentage. That's why the correlation is kind of very less when we think
okay.
about like the number of deaths there.
Yeah.
Okay,
But yeah.
when now when we are modeling the
Mm,
traffic related deaths. So drunken drive, let's say, I'm just saying actually,
mm,
not adhering to, let's say in a worst, in a scenario, let's say, not adhering to traffic rules or fast driving. Let's say
mm,
fast driving has a correlation of 0.98.
mm,
Okay, drunk driving might have like a very less effect because not all drunk and drug drivers will, end up dead, and
mm,
many people might not be drinking as such.
mm.
So that's a that's like little. I
Yeah.
hope I explained
I
little bit
understand. Yeah,
actually.
yeah, I get that it is like a thin fine line there. But then
Uh,
what I want to know is that like okay, of course we are using correlation, the higher correlations as the primary ones for our models, building the models. But then like what are we going to do with the causations then? Because you
so
said right, like initially like correlation and causations are the two main things that we need to kind of figure out. And so now we know, of course, we know the correlations, yes.
we
So we
improve.
know the top correlations and so on. We can build the model. How we are going to use causation? Should we use? That's my
Yes,
question
we
basically.
should definitely use causation actually. Usually,
Mm,
whenever we use causations, right?
mm,
So when the data is statistically significant, and if the data is of good quality, the causation factors. will improve the confidence score of the model.
Okay.
The
So that will
causation
be
factors
basic.
will,
Yeah.
yeah, yes.
So basically, like say when we build this linear regression model, so then if we include the causation, like say number of practice exams done or something, then that's going to improve the score. So there is no separate kind of what do you say method or something for causation specific modeling, right?
Yeah, we do have, I mean, basically then it becomes the mathematical technique.
Okay.
So how do we how do we model it? For
Mm,
example, uh, okay, so let's say traffic congestion. If somebody is
mm,
modeling a traffic congestion, okay, we
mm,
all know that actually traffic congestion is higher on weekdays,
mm.
right?
Yeah.
And then the traffic congestion is kind of not that high, at least at like in the office hours, like let's say 10 o'clock. Let's take Bangalore. 10 o'clock Bangalore traffic, traffic congestion is higher on weekdays. On Saturday and Sunday, it might not be that much, but in the evening, it might be too much, right? So this
Yes.
is a social behavior.
Mm,
So as such, when you're mathematically modeling it, so then you need to treat that causation of time, in terms of weekdays and weekends
mm.
separately. Okay,
Okay.
then actually you can make the model much better. I hope
Mm,
I kind of,
okay.
yeah, yeah.
Okay.
So there are like techniques actually. Then you need to know, like, you need to be a subject matter expert. You need to be a little bit analytical and mathematical actually to kind of use causation.
Okay. Okay.
Correlation
So
is
yeah.
much simpler to use. Causation is kind of requires a lot of fine tuning.
Oh, okay. Okay.
Yes.
And
Yeah.
one question.
Yeah.
So now,
Just a
like say
second.
for example, yeah, you tried. I mean, like say, of course, you showed us like say two different cases, and of course, we can build on that like different cases, making use of different columns or data for generating the model, right? So what was my questions? So. Um, Yeah, is there a way, because I'm just wondering, like, say, because is there an automated way wherein the system itself, like, say, the program itself, tries to kind of do this kind of calculate the coefficients, intercepts, and R2 scores, uh, uh, you know, iteratively, like, say, using different sets of columns instead of us defining, okay, use this as this case model, and so on and so on. Just wondering, like, is there a possibility like that?
Yeah, yeah,
So.
that's what actually this neural network example that I showed you did.
Okay, okay. That's the one that it does. Okay. Uh-huh.
Yeah, the neural
I think
network
that
actually.
correlation matrix also helps, right? Like in this angle, you can create, for example, correlation kind of a matrix even for the coefficients and other things as well. So the matrix
Mm,
you can create between the columns.
Yeah, the
okay.
matrix helps actually if you are using neural networks, right? For example, here it is trying itself actually. For example, as you can see in the
Mm,
beginning, in the first epoch, can you see the screen?
yeah.
So in the first epoch, actually, the error is like 38%, and then the new,
Okay.
without even without we telling it like any correlation or like anything, it
Mm,
itself kind of does like these things,
okay. Okay.
and then actually it's improving. At some
Okay.
point, actually, it's not worth improving, I guess. Okay,
Okay.
let me show you. Actually, it's kind of very interesting. Actually, for
Mm,
example, okay, yeah. Sometimes it's improve. Yeah, it's improve. Yeah, it improved actually most of the time. But again, it doesn't necessarily mean actually it improves next time. Sometimes actually
okay.
the
Okay.
error might go up. So
Okay.
it's a neural networks is like a little bit. Yeah.
So
Uh,
these are basically paths, can we say like that? So different paths it takes, and we are getting that scores there.
yes. Yes. Yeah.
Okay. And then out of these, it like say the best one is automatically selected, or how we like we do that
No,
programmatically or something.
basically, okay, it again depends on the method and stuff. So,
Okay.
so it basically here I said that I actually do only 20 iterations.
Okay. Okay. So that you are given a limitation for that.
I
Okay.
gave it limitation because actually even 20 iterations took like a lot of time. So
Okay. Okay.
that's sure.
And in your real world case, like for example, because you are practically doing this in your work, so is it like usually like you're using this neural networks there or something else?
Okay, so basically, mean, at least in our case, is like little different. So we didn't use neural networks, but
Okay.
we used a method based on neural networks. Yes, as I said,
Okay.
actually, we don't need to know all these things. Okay,
Okay.
so in my work, actually, I'm using this concept called like nearest neighbor.
Okay.
So I'm using like this concept called nearest neighbor.
Okay.
So by using, somebody has developed a method. I don't need to kind of take that method, but I
Mm,
need to take that method and do that fine tuning actually. I should
okay.
tell then when I take that method, right, then I should tell
Mm,
actually where it should look for the nearest neighbor.
okay. Okay. Okay.
Yeah. So
And yeah,
basically,
okay, yeah, that's good because just wanted to get your like say the practical kind of a thing, what kind of models that you use or something. So
yeah.
the scikit-learn is basically like I would say for a simple mathematical kind of basis. So it's for beginners, then that is the right place to start,
No,
and then
thing is like,
progressively.
for example, I mean, I'm just okay. Cosine distance, cosine similarity. I think it's part of. I'm just thinking actually which package it is. I think it is scikit-learn only.
Okay.
Yeah. So basically, I'm using this package actually. So this particular, in my work, we have technically implemented actually this scikit-learn
Hmm.
cosine similarity distance.
Oh,
You
okay.
need to know
Okay.
method actually. It's basically
Okay.
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 You need to know method.
Okay.
For example, I know this method. I know actually the nearest neighbor is something that I'm looking for, and
Mm,
even I don't know. When I implement it is I myself doesn't know about this. I myself doesn't know about cosine similarity, but
okay.
I do know that actually okay. The problem that I'm seeing is the nearest neighbor,
Mm,
and basically this cosine function matter. Yeah, it's complicated. So not complicated. Basically, you just kind of search for it.
yeah.
If you know
Okay.
what
Yeah.
you're
Yeah.
looking
It's
for, yeah,
okay.
if you know what you're looking for, then you just, then I just kind of identified it. And then I
Mm,
applied cosine similarity as it is. It didn't work. Then I
mm,
kind of did fine tuning actually for our use case. Then it
okay. Okay.
worked really great.
Mm,
And it worked to an extent that actually we do generate fuel events. Actually, the fuel events are like synchronous and whatever.
mm,
So we are able to pinpoint the mistakes to very
mm.
fine detail.
Okay. Okay. Okay.
Yes. Yeah. Thanks. Yeah.
And also practically when we, for example, after we develop this model, this pickle file, and usually it's deployed and it's then used like using APIs or like something like that. And then of course then there could be again a retraining with the fresh set of data. And then of course
Yeah.
a new version of model is deployed and so on. That's how the
Yeah. And
deployment model,
that's
right?
how
Yeah.
that's
Yeah.
how the workflow works.
Okay.
For example,
Okay.
like this API that we have deployed, right? Like for the salary prediction model.
Mm,
So every time you just post the message, like, it just gives us like the input, the output, like something similar just
mm.
happens. Yeah.
Okay. Yeah. Okay. Great.
Thanks.
Great. Thanks for the clear
Yeah.
explanation.
Thanks.
Thank you.
And any comments, Surendra? Actually, I saw some comments or something. No.
No comments. Like I think we are good. Okay, so yeah,
See,
Vaishnavi.
Vaishnavi, actually. Yes.
Sir, as you said that underfitting and overfitting, so I have a doubt that does underfitting and overfitting affect the machine learning model while providing the accuracy and efficiency?
Okay. See, basically, okay, uh, we are the ones who should be able to determine whether the model is underfit or overfit. If it is overfit, right, uh, that's not good. If it is underfit, that's not good. So
So,
I hope you understand my answer. Like, so as a person, as a modeling person, like we should be able to know what is overfit and what is underfit. That model
okay,
itself cannot tell everything, right? Sometimes
okay,
what
get
happens is that like, we might use a method actually which might be overfitting and usually overfit, it also costs money, time, resources, and stuff. So as I showed in that example, for this particular student performance index, using neural networks is if we use a better algorithm in neural networks, I think that uses like random forest, I guess, that what I did. If you use like some other better algorithm, then it might overfit it, and overfitting might, it might take more computing time. It might not be even needed, right? Like if it is just a student performance index, why we need to overfit the model?
Okay.
You,
So
you get what I mean?
while training the model only, we have to get to know that which is perfect to this model. Like ratio will be there, right?
While preparing the model, say again.
So
Say
while
again.
before training the model only, we have to know that whether this comes under like it comes under the underfit or else overfitting.
Yeah, that's why actually, we will be able to, if we do better data exploration and preparation, right? Better data
Okay.
exploration and preparation, we would be able to identify the patterns. Like, that's why we have tested the data set. With the
Okay.
tested data set, we will be able to know whether it's a overfit or underfit. And
Okay. Fine.
and with the test data set, and in general, actually, for overfit and underfit, right, they use like some sort of a model scoring, actually, some sort of a model scoring. And the methods might sound like, okay, if you look at those equations, they might look like kind of very threatening, I mean, no, difficult, but once you start kind of decoding it, right, they are very simple. Yeah, I hope I answered your question. Is that so?
Yeah. Yeah, sir. Thank you.
Yeah. Any other question? Like, yeah. So yeah, if we don't have any other questions, so Surendra, do you have anything to add, or maybe
Yeah.
let me go? Yes.
Yeah, please, Srikanth, go ahead.
Yeah. So basically, actually, all of you has access to this, the notebook. You can little bit go through that notebook. Try to use that notebook and play around. Maybe if you want, actually, you have, we have given a link to Kaggle. So just go there and go there and look for multivariable regression models, and just download the data set. What you just need to do is like you put that same the CSV file in the same folder, and change the name and run the same commands. Okay, so it should work. Okay, you need to change the headers and stuff, but if you are just using training, ML model training, even let me show the screen actually. So if you want to do it, like just do this, maybe take it out, like just load the packages, and just change the salary data, basically the file name here, and change the file names. And after that, just identify what is the variable that you want to predict, and put that variable to y here, put that variable to y, put everything else to x, and then just run this. This code is reusable actually. So, and here just change, you can just reuse the code for n number of times for the same, for different data sets. Yeah. So yeah, anything else? Like I think we finished like little early than anticipated. So do post your questions or something, if you have any in the Discord channel, I will try to answer if you have any questions on assignments and stuff. I hope you understood. Sure, I will just tell you, like, I mean, those of you, if you understand, like, kind of, it fine. But if you are not able to follow, I will tell you only 5 points to remember after this event, after this lecture. I will again reiterate. Machine learning models are used for decision making, and linear regression is one of the most popular method in making predictions. And we can make machine learning models by using linear regression. And we have this package called like scikit-learn, and we can use that scikit-learn and then make many machine learning models. Once you start using it, you will learn how to use it. That's one. The other one, The next is like you need to understand machine learning workflow. Even when you make like AI agent workflow, right, it would be something similar. Basically, whenever if you want to work in IT, you need to understand the workflows. We have DevOps workflows, we have machine learning workflows, we have maybe even in testing, they have their own workflows. In data engineering, they have their own workflows. So it's basically you just need to know the machine learning workflow. The machine learning workflow will have like a uh, goal, data exploration, preparation, training, and validation, deployment, and monitor. So these are other. This is another point. The other point is actually, whenever you're using machine learning models, you need to know a little bit, how confident. You need to tell, like, if you are using, even when you applied a method, you don't need to develop a model. If whenever you're using it, you have to tell the people who are going to use. This is the confidence factor.